right, so we are going to do a day 2 on packet number 3 today. So this is part of last night's homework. So what I would like for you guys to do is to hold up your Plickers card and show me which answer you got for 4. All right, so some people picked A, B, C, and who knows if you picked D or E. Okay, so if this is the second derivative, what do we know about a point of inflection for the second derivative? Where do we start? Yeah. So we need to start with the second derivative equaling 0, right? So that would be x plus 1 and then x minus 2 squared. All right, now that thing is already the second derivative and it's already factored, which are both really nice. So we get 3 numbers, and this is why I think some of you thought the answer was E. I'm going to go ahead and tell you that it's not E. We call these possible points of inflection. I don't know yet that the sign of H double prime is actually changing around here. Can any of you tell me one that you know is not it based off of just your knowledge of how to do these problems?
2.
Why is x equals 2 not?
Squared.
Because that term was squared. So if you recognize this next time, you could say that's not going to give me a point of inflection, which would make the answer C. Now, if you don't recognize that, then you're going to have to go through and do a sign chart. And what would end up happening here is you'd get plus, minus, plus, plus. All right?
Because 2 is a saddle point.
2, yeah. 2, there's no change. It's not even a saddle point necessarily. But there's no change in concavity there.
So you know that because it's squared.
Because this thing has an even power. So it's like when you did rational functions in pre-cal and you had that it was together or tangent when a term was squared. It's the same situation happening here. Okay, let's look at number 14. Whoops, here we go. All right, so again, I want you to hold up your Plickers card and let me know what you think the answer is. All right, so looking at this picture, this is the graph of f. So f of 1, that would be the y value. What is that in this problem?
0.
0. Okay. What about f prime of 1? What would that be? In general, it would be the slope. In this problem, that has a positive slope. So what about f double prime? Yeah. It's in general, it's the concavity. This is concave down. So we would do negative. And so which one of these has to be the least amount? F double prime. Which one is next in line? F. This is how you would approach this problem. So the correct answer was D. Okay. All right. Let's go back, and I want to work number 8. This was one you might have already done, and if you're like, if you feel pretty good about this one, then you can just work on whatever. But this is a calculator problem, and we didn't get to this yesterday. So I want to talk about how we use our calculator to answer a question like this. So one thing you could do, and I'm on number 8, by the way. One thing we could do here is you're given an f of x, and you want to know about a change in concavity, basically a point of inflection. You could take the first derivative, then take the second derivative, then set that thing equal to 0, then make a sign chart, then test the sign chart. That's a lot of work, and for a trig even, that's complicated. So we're going to do this by graphing, okay? And you can actually just graph that f of x the way it is right there. So if we go to y equals, and I'm going to encourage you to all type this in. You will never, ever, ever, ever get better at using this calculator unless you actually use the calculator. If you could get better at it by watching me, that would be great. That is not the reality of the world we're living in. Yeah. Okay. So there's f of x. And I don't really want to see all of this graph. Look at your answer choices. These are supposed to represent x. What are they all between? Let's narrow down our x window.
0.5 and 2.5.
Yeah, 0 and I think 3 is a good answer because there's a 2.44 there and 3 is a little bit bigger. I don't care about anything outside of this window. So I don't want to look at anything outside of this window. Please make sure you're in radians mode since this is a trig problem. By the way, if your calculator says BATT anywhere down here, your batteries are going to die very, very soon. All right,
How do
we
you switch from radian to
go to mode, and then you go down here where it says change it from radian to angle. I mean, the other way around. Make sure it says radian. Okay, if you do diamond F3, since diamond is the same color as graph, we're going to look at this graph. And remember, I am graphing F prime. So it's very straightforward. I want to know where this graph changes concavity. What's the concavity at the beginning of this problem? Down. And then it changes to up. Okay, so somewhere in here, this graph changes concavity. It looks like that's a little bit less than 1. So a good, if you knew nothing else at this point, what would you guess?
0.93.
B, 0.93. That does end up being the answer. We're going to find it exactly, though, because sometimes the answer choices are trickier. If you press F5, see number choice 8 is inflection. We hardly ever use this one, but this is a time when you could use it. It is going to give you the whole lower bound, upper bound thing. All you need to do is go to the left of where you think the point of inflection is. We said it was probably right around here, so make sure you're to the left. And then you press enter and it changes to upper bound, and then you're going to go to the right of where you think the point of inflection is. Don't go too far to the right. Okay? 0.93, that's the answer. All right, now there are times, and I don't want to make this problem more complicated than it is here, but I will tell you what's more likely to happen is that they give you F prime. Okay, so what I would like to do in the calculator is to show you what would happen if they gave you F prime and like how we would do this, and you're going to see we're going to get the same answer. Now you could get your calculator to do the derivative here. That would probably be a wiser choice. I'm going to go ahead and derive this thing by hand just for review. Derivative of cosine is going to be negative sine. You would keep, well, that's not right. Here we go. Negative sine. Come on. There we go. Nope, not that one. Okay. And then we're going to type in the exact same thing, 2x. And then we're going to multiply by the derivative of the inside, which would be 2. Okay, you could use your calculator here to find the derivative. We're just doing this for review. How do we derive natural log functions? 1 divided by, I'm going to actually hit divided by, and then I'm going to use parentheses, 3x. And then I got to go times the derivative of the inside, so times 3. All right, again, you could have used your calculator to find that derivative. This was just a quick little review. Look what this graph looks like. It's going to be a little bit different. This is the graph of f prime. So if I'm still looking for a point of inflection on f, but I'm given f prime, I'm not looking for this graph's point of inflection. What would I be looking at for this graph, which is f prime? So I heard a few different things, but let me make sure we get this. Let me skip to f double prime really quick. If this had been f double prime, we would just look for a simple change plus to minus, minus to plus.
Oh, sorry.
So if this is f prime, we actually want to look for the extrema, maxes and mins. Do you know how to find, well, something just happened there. That's okay. Do you know how to find the maxes and mins on your calculator? It's right there in F5. And we would look for a minimum in this case. And again, you got this lower bound, upper bound thing. If you still don't know how to do the lower bound, upper bound thing, you got some time to figure that out, and you need to. because this right here is a necessary skill in using all this. So we're still going to get 0.93. Okay, now if I had taken the time to find f double prime and graphed f double prime, I would look to see where it crosses the x-axis, f50. All right, if you look at number 10 on the same page, notice what they give you on 10. It's a calculator problem. They give you f prime and ask you about the points of inflection. Notice the window. They're giving you the window, by the way, there. So make yourself a note of that. All right. What I'm going to do now is work a couple of free response questions. If you would rather at this point just work by yourself, feel free. Your goal is to finish this packet by tomorrow. Okay? So if you want to work with me, work with me. If you're like, I'm way faster than you, that's cool too. It's not going to hurt my feelings if you're working on a different problem. I want to skip to problem 24, which is a free response though. A lot of people were telling me they wanted me to work more free response in class. And super blurry, I know, but you have this right in front of you, so it'll be okay. All right, now we had one of these on the mini mock exam. Do you guys remember how I drew on the boxes here? Yeah, so in the f prime row, if it says negative, I'm going to draw a little decrease. Okay, so decrease, increase. That's on the f prime row. On the f double prime, that's concavity. So make your concavities. And this is going to help you with the rest of this problem, I think.
Can we use colors on it? No.
Let me double check about that. I feel like I know the answer to that, but I'm not sure. What are they asking you to find in part A? Absolute max and min. Do you know what they are based off of the table?
Yep.
That would be a point of inflection. But the absolute max or min is going to be like the absolute highest and lowest point. Honestly, I don't feel like it's that obvious looking at the table. Okay, part A does not have to be the easiest part. In this case, I think it's the hardest part. I'm going to skip it. Now I'm going to move to part B, which part B does say find the x-coordinate, so x equals, for each point of inflection. That means there could be one, there could be more than one, it's possible there could be none on the graph of f. So what would our justification be? Sometimes writing the justification can help you figure out for a point of inflection. F double prime changes signs. You need to either have F double prime or F prime in your justification. In this case, it makes more sense to use F double prime, changes signs, because that's an easier thing to look up. It would be very difficult here to figure out where F prime had extrema, just based off the chart. So, what do we got? X equals 1, and that's it. That's the only answer. Okay, look what they're asking you to do in part C. Graph F. Sometimes these are really tough. Sometimes they give you a lot of hints. So if you look at the table, they're actually giving you whole points to plot. So see how this f of x row, that's just like y. So they're telling you to plot the point 0, 1. What other point are you supposed to plot? 1, 0. I'm just looking it up right here. And 2, negative 1. Who knows? You could get a point just for doing that. I'm going to switch colors just to kind of make it a little bit more obvious. Here, I'm going to put these in red. Okay, so we got to connect these, and we got to follow the trends that they tell us to. So we got to, from 0 to 1, from these 2 points, you got to decrease, and you got to go concave up. So when you decrease, it cannot be a straight line, okay? It needs to bend upwards like this. Okay, please make sure yours has concavity. Be exaggerated about it if you need to. All of your things here are going to look like this. It's kind of almost like parts of a circle. So do you have an idea of what's going to happen in the next group from 1 to 2? Concave down and decrease. And the decrease part was more obvious, and then just make sure your concavity is clearly down. If you don't feel like it's curved enough, erase it and make it clear. Don't let the AP grader try to figure out what your concavity is. Make it clear. All right. We do have one little more piece of graph here. I don't know, like for x equals 3, I don't know where the y value should be, but I know that the y's in between 2 and 3 should stay negative. So below the x-axis, I know that I should increase and have concave down. So I'm going to do something like this. If you made it go all the way to the x-axis, that would actually be okay. But you can't have it cross the x-axis because of that thing right there. It says that the y values should be negative on this interval. What do we call this point down here at the bottom? What type of point is that? A cusp. What's the derivative at a cusp? Undefined. That's why that's right there in your table. All right, now that we have the graph, part A is way easier. Do you see where the absolute minimum of the graph is? It's right down here. So the question is, do you write the x or the y value? It depends upon the question. If the question is, what is the absolute min? You would say -1, the y value. But this one says, find the x coordinate. So we would say, at x equals 2. Okay, so go ahead and write a similar statement for the max. All right, what is it? At x equals 0. All right, let's do 26. And again, if you want to work on something else, you are free to do that. Okay, 26 is kind of weirder. This is a perfect example of when parts C and D are easier than parts A and B. Okay, you're going to see that. We don't really have to do much work at all for C and D. So A and B are going to be kind of weird. In fact, here's what I'm going to do. I'm going to just go ahead and write this on a new page. So, okay, they give you h prime is x squared minus 2 over x. And they say, obviously, this is for x not equal to 0. They also tell you that h of 4 is -3. And then for part A, you want to know where h has horizontal tangents. So what do we know about a horizontal line? Yeah, in particular, maybe the slope. 0. I want to know where h prime, of x equals 0. I want to know where x squared minus 2 over x equals 0. If a fraction equals 0, what part of the fraction is actually equaling 0? The top. So x squared minus 2 equals 0. Add the 2 over. You get x squared equals 2. So x is plus minus radical 2. Okay, and we're going to put those on a chart. Now, are there any other critical numbers? I only have to talk about these two. But if I have other critical numbers, I should probably put them on my sign chart just to, it's going to help you. So are there any other critical numbers to that? Where h prime equals 0 or h prime is undefined? 0. Okay, so down here, I'm going to put this in parentheses. This is not a horizontal tangent. This is actually a vertical tangent or an undefined, okay? But it's still a critical number, so we're going to put it on the chart. But when I do my analysis down here, I'm not even going to talk about 0. All right, let's go ahead and test. And remember what you're testing into. We're testing into H prime. So what happens when you take a number less than negative root 2? So I'm just going to go big. Negative 10. Is the result positive or negative into H prime? Negative. So that tells me that H is decreasing from negative infinity to negative root 2. Probably what's going to happen next? Probably it's going to be positive. You can easily test that out with a negative 1. Okay, that gives you a negative over a negative. That is a positive. And probably it's going to alternate. It's always good to check if you're not sure, but it does in this case. So we don't need, it's talking about at the horizontal tangents. Okay, so at x equals negative root 2, what do we have? H has a relative min. We want a justification because H prime changes from negative to positive. We do not have to talk about that there's a max at 0. I'm going to go ahead and write all this again. This is all part A, but I already told you this is the hardest part. You would have been fine here to just go ahead and, whoops, that's not what I meant to write. Sorry, that's what I get for talking and writing. Okay, here we go. You would have been fine here to say at x equals negative root 2 and positive root 2. That would have been fine. I just wrote it twice. I don't know, because that's the way I like to do things. So although that was kind of straightforward, it was a lot of work. What I mean by straightforward is you have done a problem like this. If you've done what I've asked you to do this year 30 times at least, you've done relative mins and maxes. It doesn't mean you remember it that well, but I'm saying you should be able to know the process here. Okay, what are they asking us on part B? When H is what? Concave up. So if I knew where H prime was increasing, then that would be how I do this, but I don't know this. So I'm going to just go ahead and find H double prime and repeat the process of the sign chart. Okay, H double prime. How are we finding that derivative? Hang with me here. I told you parts A and B are a little gross, C and D really easy. I need to, and I'm going to use quotient rule. Okay, so derivative of the top times the bottom minus the top times derivative of the bottom over the bottom squared. And if I'm going to have to analyze this, it's going to be to my own advantage to go ahead and simplify, and I'm going to distribute that negative. So I need to find out my possible points of inflection so then I can figure out concave up when H double prime is either 0 or undefined. So it's basically where the top equals 0 and where the bottom equals 0. Okay, what answers does the top give you? If you said x squared plus 2 equal to 0, what happens when you subtract 2 and try to square root? You get a square root of a negative, which we get to not do. Okay, that's an imaginary solution. What about x squared equal to 0? Okay, so we are going to go ahead and do another sign chart, this time with H double prime. We only have 2 things to test. And if you look at this, that thing's always going to be what? This thing, it's going to have to be positive, except for when x is 0, of course. But H double prime has to be positive. So concave up, concave up. You see how that's back to back? That's because of the squared on the x. So we would say, when is this thing concave up? Well, here, because H double prime is positive. And you can say positive, you can say greater than 0, however, whatever you want to do there. All right, we did the harder parts of this problem. Part C is actually a lot easier because it's a tangent line. And they all but give you all this information. So what do you need to write a tangent line? A point and a slope. And they tell you tangent line at x equals 4. So we need the point to be at 4 comma something. How are we going to find that something? Right here. What? They give it to us. What is it? It's -3. They gave it to us at the very beginning. The slope. How are we going to find the slope? Plug it into the derivative. You know what? I'm not going to simplify. That's it. That's it for C. What I'm afraid happens on these problems is students get so bogged down with A and B, they're just like, I give up. I'm going to draw a picture of a teddy bear. Okay, don't do that. Part C could be really easy. All right, part D. Does the tangent line to the graph of at H at x equals 4 lie above or below? This actually has to do with concavity. What did we just figure out about concavity in part B? Always concave up. So I'm going to draw a picture of concave up, and I'm going to draw a picture of a tangent line. And what do you notice about the tangent line to H? Yep. So how would we answer the question? The line is below H of x. I don't know why I put that. That was weird. No derivative there. H of x. And we need to say how we knew this. Well, we know that H of x is concave up. You don't really have to put a whole lot more into that because you already proved why it was concave up. Okay, so when you're trying to figure out if a tangent line is above or below, you got to use concavity.